Okay, here's an Ampere's law question that I suspect when you first look at it, you think, oh my gosh, how could I possibly do this? So we'll just walk through it and see that it's not so bad. It's really looking at this integral of b dot dl. Remember, the dot product says you want the component of dl, that of the magnetic field, that's parallel to dl, the direction you're moving. As we go around this loop from 1 to 2, from 2 to 3, and then from 3 back to 1. So it's probably a good idea to start by going in and writing out the magnetic field produced by these currents. Notice the current is going into the page, so I stick my thumb into the page and notice that my fingers go around in the following direction. Well, one thing we know from Ampere's law is that the integral of b dot dl is mu naught I enclosed, the current enclosed. And there's no current enclosed here, so we need the integral of this entire thing to be 0. So it can't be a because that has a positive integral. So it's either b or c, and this is a good thing about multiple choice is we can kind of look at the difference, and it seems like we'll be able to get the answer mainly by looking at the signs where things are positive or negative. And so there, we got rid of case A. We know it should fall off like 1 over r, the distance from the wire. That's true. But for me, the easiest one is looking from 3 to 1, this top segment here. I'm always going to the right. The magnetic field from these is pointing a bit to the left, so I'd expect to have a negative contribution in the segment from 3 to 1. Diagram B has that. Diagram C has a positive contribution there. And so I'm going to go with diagram B, and I am correct.